Welcome back everyone to our factoring difference of cubes examples video. We have an intro video that talks about how to work through the basics of sum and difference of cubes. Here we're just doing examples with difference of cubes, so that will be something cubed with subtract in between with those two terms. My first example here, we have 64x cubed minus 125. So I want to figure out what my a and b are in my formula. So what is being cubed to give me 64x cubed? Well, 64 is 4 cubed, and obviously x cubed is x cubed. And 125 is actually 5 cubed, so all of these are perfect cubes. And we have subtract, it's a difference of cubes. So here we're saying in our formula we are going to use a is 4x, and b is 5. Okay, so going over here, we will say 64x cubed minus 125 equals short factor with a and b. We'll have 4x and 5. Long factor, a squared, ab, and b squared, right? So square of the front goes in front. Squaring 4x will give you 16x squared. Square of the back goes in back, so 5 squared would give us 25. And multiplying in the middle, a times b, 4x times 5 will give us 20x for our middle term in the long factor. Going back and assigning SOAP now, using our SOAP from our intro video. So if I use the same for the first term, that would make this a minus, same as what we started with. Opposite of what we started with would be plus for the next one, and always plus or always positive for the last one. So we get 4x minus 5 as our short factor. Long factor is 16x squared plus 20x plus 25. Our next example, x cubed minus 216. 216 sort of tends to be this maybe close to the last number that an instructor might expect you to know for perfect cubes. Some of them want you to know up to 10 cubed. 10 cubed is easy, but 7, 8, and 9 get a little big. But they like you, I think, probably to know up to 216 in general if you're doing cubes. I think maybe it's just so that they have some options to write problems. So here we have x cubed, 216, this is 6 cubed. And we have minus in the middle, difference of cubes there, with a being x in this example, and b being 6. So if we plug our a's and b's into our formula for x cubed minus 216, a and b are x and 6. The square of the front goes in front, so x square that, we would get x squared. If we have 6 and we square that, the square of the back goes in back, that gets 36 for our last term, and then x times 6 multiply in the middle will give us 6x. Using SOAP, we start with minus, so same would be minus, opposite would be plus, and always plus will give us add for the last term. X minus 6 times the quantity x squared plus 6x plus 36. Okay, let's look at our last one here. We have 3x cubed minus 81. We have a little bit of a problem here in that 3 is not a perfect cube. 81, not so much a perfect cube either. So this one, you might notice first that we have a greatest common factor. Always check for greatest common factor first before you do any other methods of factoring. So I see that these have in common a 3. I can pull out 3 as the GCF, and left over we will have x cubed minus 27. So then looking in here and seeing what cubed gives me x cubed, well, a is going to be x in this scenario. What cubed will give me 27? 3 cubed will give me 27, so x and 3 are what we will use in our formula. I'm going to go ahead and keep my 3 out front already factored. And we will use the rest of the space to do our difference of cubes stuff here. So I'll keep my 3. And then I'll start my short factor in these brackets. So x and 3 go in my short factor. And the square of the front in front would be x squared. The square of the back term in the short factor in the back would be 9. And multiplying in the middle, x times 3 would give us 3x. Applying SOAP, if we start with minus, then same will be minus, opposite will be plus, always plus, of course, in the back. Okay, and we have those two factors, and then we also have our 3 out front. We can write it without the brackets if we prefer. We can say 3x minus 3 x squared plus 3x plus 9. And that is our fully factored version of this last problem. Okay, that's all of our videos on cubes, both sum and difference. Check out the other ones if you haven't yet. Hope these help you with your factoring of cubes.